Welcome back, scholars. Today we're going to look at Chapter 3, Big Idea Number 2, Solving Quadratic Equations by Graphing. So today our learning targets are, I am learning to solve quadratic equations by graphing, and I'm learning to estimate solutions of quadratic equations by graphing. So quadratic equations are quadratic functions that are set equal to a value. Typically, this value will always be 0. If it's not, we're going to manipulate it to where it becomes equal to 0. So the standard form of a quadratic equation is ax squared plus bx plus c equals 0. And here, a can never ever equal 0, and a, b, and c must be integers. So when we take a look, the solutions of a quadratic equation are often called roots. Roots are often called zeros. They're interchangeable, and we can even call them solutions, which means the function either crosses or touches the x-axis. So we're going to take a look at some examples. We are going to solve by graphing. So first things first, we're going to take what we learned in big concept number 1 and apply it here. We're going to look for that axis of symmetry first. So axis of symmetry says x equals negative b over 2a. So in this case, we have a equals 1, b equals negative 3, and c equals negative 4. So here we have negative b, which is positive 3 over 2 times 1. So here we get 1.5. So I know my axis of symmetry is at 1.5. So I'm going to go over here and I'm going to do my little dash along 1.5. So it's just for a frame of reference for us. We know that we're going to be symmetric across that axis of symmetry of x equals 1.5. All right, now we have to find that vertex, which is f of negative b over 2a is that y value. So first, we go 1.5 squared minus 3 times 1.5 minus 4. And what we get here is negative 6.25. So our vertex is the negative b over 2a, which is 1.5, and our f of negative b over 2a, which is negative 6.25. So now we're going to plot the value 1.5, negative 6.25. Well, here's our axis of symmetry. 6 is right around here, so we're going to say 6.25 is right here. So there's my vertex at negative 1 or at 1.5, negative 6.25. All right, our y-intercept is what? It equals c, which in this case is negative 4, so we have 0, negative 4. All right, so I'm going to go down. I'm going to plot 0, negative 4. Now, if I went to negative 4 over here, that means at 3, I also have negative 4. So now we're going to draw that smooth curve. So what we see when we have drawn our smooth curve is that my parabola intersects at 2 additional points. Negative 1 and 4. These are my solutions. These are my zeros. We have 2 zeros at x equals negative 1 and x equals 4. So all we did was estimate. We estimated that our graph intersects the x-axis at negative 1 and positive 4. So that example is done. So let's go on to this next example. We have A, B, and C. However, notice right now we do not equal 0, so we need to make sure that one side does equal 0. Right now I'm sitting with that negative x squared. I don't know about y'all, but I don't care for a negative x squared unless I absolutely need it. So let's go ahead and we're going to add x squared to both sides. And we're going to also subtract that 14. When that happens, I get 0 equals positive x squared minus 6x plus 9. So now we have a is 1, b is negative 6, and c is 9. So axis of symmetry is the equation x equals negative b over 2a. So in this case, negative b is a positive 6 over 2 times 1, which is 3. So now I'm going to make sure to draw that dashed line, my axis of symmetry at 3. Here's 3. It's not perfect, it's just for reference that that is my axis of symmetry. Next, we're going to find the vertex, which is the point negative b over 2a, comma, f of negative b over 2a. Well, we already know what negative b over 2a is. It's 3. So in actuality, we're only looking for 3 and f of 3. So f of 3 is 0 equals, or well, not 0, silly Miss Younger. We're just substituting it. So 3 squared minus 6 times 3 plus 9, which gets us a nice value of 9 minus 18, 0. Cool. So we know our vertex is actually 3, 0. So I'm going to go down and I'm going to plot my vertex at 3, 0. All right, because A is positive, we know that this is going to have a minimum. So this is my lowest point. Our y-intercept is 9. So we go to 9 here, which means at 6, I'm also at 9. Now we're going to do our smooth curve. Okay, looking at our x-axis, we've only touched it this time one time. So there's 1, 0 at x equals 3, which means it has one real solution. This example had 2 real solutions. This example has 1 real solution because this one touches, while these ones cross. This parabola touches the x-axis, this parabola crosses the x-axis. All right, going on, we have another example. So let's find our A, which is -1, our B, which is 15, and our C, which is -63. So our axis of symmetry states x equals -b over 2a. So in this case, we have 15, -15 over 2 times -1, which is 7.5. So I'm going to put down my invisible dashed line at 7.5. Just for that frame of reference. You can erase it later. You can keep it. Mrs. Younger does not care. Our vertex is a point of -b over 2a, comma, f of -b over 2a. However, I know what -b over 2a is. It's 7.5. So this is actually 7.5, comma, f of 7.5. So let's actually substitute in. We have -7.5 squared plus 15 times 7.5 minus 63. So if we were to put this into our handy dandy calculator, we actually get a value of -6.75. So our vertex is actually the point 7.5, comma, -6.75. So let's go down. Here's 6, here's 7. So it'll be right around here. All right, A is negative, which means this is a maximum. We will not have any value above, and then our y-intercept is C, which is -63. Wow. Do I even have room for -63? No. So when I draw this smooth curve, I'm going to get close to that y-axis, but I'm actually not going to touch it. All right, so I now have graphed that smooth curve. Let's see where it crosses our x-axis. Well, here's our x-axis. Does our parabola cross it or does it touch it? Well, if you said neither, you would be correct. There are no real zeros because it does not cross that x-axis, which means there's no real solutions. So keep that in mind. Here is a little graphic to help you remember one real solution, two real solutions, and no real solutions. Often, those exact solutions cannot be determined by graphing. We are pretty lucky. But you can actually estimate by stating the integers between which the roots are located. So basically, you take a look at this table of values. When your y values switch from positive to negative or negative to positive, that means you have a 0. So taking a look, we have positive 12, positive 3, negative 6. So because I went from a positive to a negative, there's a 0 located in between x is negative 2 and x is negative 1. Notice these are consecutive integers. Integers right next to each other. All right, then we're negative to negative, no problem, negative to positive, because we had that sign change, we have an additional 0. So we have 2 zeros in this graph, so that means I'm going to have 2 real solutions. All right, so let's take a look at this next example. It has a lot going on. It says, solve x squared minus 6x plus 4 equals 0 by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. So let's start off with the easy. A equals 1, B equals negative 6, C equals 4. So axis of symmetry states x equals negative b over 2a. So in this case, it's 6 over 2 times 1, which is 3. So I'm going to have my dashed line at 3. So x equals 3. That is my axis of symmetry. My vertex is the point negative b over 2a, comma, f of negative b over 2a. Negative b over 2a, we just found out, is 3. So we're actually looking for 3 and f of 3. F of 3 is 3 squared minus 6 times 3 plus 4. In this case, 9 minus 18 plus 4 is negative 9 plus 4, which is negative 5. So we know our vertex is the point 3, negative 5. So I'm going to go down here. Here's my vertex. Because a is greater than 1, this right here is a minimum. That is the smallest point that we have. All right, next we have our y-intercept of C, which is 4. So I know I'm over here at 4. So if I'm at 0, 4, that means I'm at 6, 4. All right, so let's draw our smooth curve now. All right, so we have 2 zeros. So we have 2 real zeros. But we need to estimate. Right now, they're between 0 and 1 and 5 and 6. But let's make a table of values just to double check. All right, so let's make this table real quick. We have x, we have y. We know that our middle point is 3, negative 5. That is our vertex. We know our y-intercept is 0, 4. And that it has a matching point of 6, 4. So we need to find the consecutive integers in between. So that leaves us 1, oops, I Miss Younger did it. So 1 and 2, 4 and 5. All right, so we're going to double check. Looking at our graph, is it between 1 and 2 or 0 and 1? We think it's between 0 and 1. So let's go ahead and see what value of f of 1 gets us. So we're just going to show my work up here. F of 1 equals 1 squared minus 6 times 1 plus 4, which gets us negative 1. So I know 1 is negative 1, which means 5 is also negative 1. So this is where my 0 occurs, because I've gone from negative to positive. So let's go ahead and let's redraw this graph. I now know that 1 is negative 1, and 5 is also negative 1. So that's just added 2 more points onto our graph. If we were going to do f of 2, just to fill it out, we get 4 minus 12, which is negative 8, plus 4 is negative 4. So now I have 2 negative 4 and 4 negative 4. So we just added some more points. So let's go ahead and redraw that curve. All right, because I had those additional table values in my table, I was able to draw a more accurate graph. So I was able to adjust where my zeros were. So in this one, we have learned how to graph quadratic equations even more, but we also have been able to solve them by estimating their roots, by graphing, and by table. So if you end up having questions, please, please, please make sure you're emailing me, asking me in class. I am always here to help. I hope you have a wonderful day.